Good afternoon, and thank you for joining the last session of our webinar. I remind you the webinar is recorded. All attendees, it will be published on our website. All attendees are muted. In case you have any trouble or any issue, please raise your hand and I will contact you privately. For any question regarding the webinar, please do not hesitate to write them in the Q&A box on the right side of your screen, even during the event. We will answer them at the end of the presentation. I will wait a few minutes and then we will start. Thank you for your patience. Okay, thanks again for connecting to our webinar. I remind you that the webinar is recorded and will be published on our website. All attendees are muted. In case of any trouble, please do not hesitate to raise your hand and I will contact you privately. In case of any question regarding today's webinar, please do not hesitate to write them in the Q&A box on the right side of your screen. I will now give word to my colleague, Peter Balzer, who will present you today's webinar. Thank you and enjoy the event.
Hello and welcome everyone to the fifth and last part of our training. My name is Peter Balzer. I'm an application specialist for the NC joining systems. So today we have two topics. First of all, I would like to talk about our safety functions of our system. We have generally two different safety options in our system. The safety option S4 for the IndraDrive C, the safety option L4 for the IndraDrive Cs. We are only using at the moment for our special joining system, the NCFE. Then I would go on with some typical safety appliances like a light curtain, safety door, laser scanner, safety gate, and the two-hand control device. I would like to talk about the advantages and also the disadvantages for each system. Afterwards, I would easily show you how you can determine a performance level, how you need to take care of, or what about you need to take care of if we are talking about an automatic component supply and a manual component supply, what are the differences and what system you can use. And also the last topic is the responsibility. Later on, I would like to show, the next step is I would like to show you or present you our so-called joining competence center at the end of the presentation. Let's start with the safety first. So let's talk about the functions in general. So as I already said, we have generally two different safety options. Safety option S4 comes with the IndraDrive C and the safety option L4 with the IndraDrive Cs. So each joining system you're using normally comes with the safety option S4. Only with the NCFE we are using L4 option. So what means S4 and L4? So let's start with the safety option S4. Here you see the IndraDrive C and the according safety zone module. We are able to perform 4 different safety levels or 4 different safety functions. The first one is the so-called SMES. It's the safe stop 1. And if you have a look at the diagram and see what is happening at this threshold here, when someone is, for example, pushing the emergency stop button from the machine. Here you see the speed and the time, and as soon as the emergency stop button is pushed, or you can also use this function, for example, for a light curtain, as soon as the emergency stop button is pushed or the light curtain is crossed, the spindle will stop as soon as possible. So all the power on the system goes to stopping of the spindle, and we are talking about times lower than 100 milliseconds for each of our joining system. That's the safe motion emergency stop function. The second function I would like to show you is the so-called SMES T2. It's the so-called safe operating stop. This function is used for a planned stop. For example, if you imagine an assembly line with, for example, some safety doors. So you have some switches where you can, for example, ask for permission to open the door. Then all the systems will be stopped, also our spindle robots and so on. And if you are in a safe operating stop, the motor is still powered on, but there's an evaluation going on the actual displacement value. And if something goes wrong, for example, too high torque on the system or the spindle is moving, then the emergency stop function will be released. So this function is often used, for example, like I already said, in combination with some safety doors. The next function is the so-called SMM1. It's the safely limited speed. This is always used in combination with the SMS T2 function. For example, let's go back to the imagination of this assembly line. You are opening a safety door, and then you have, for example, a mobile panel with a deadman switch. And this deadman switch you can combine with this SMM1 function to allow the operator or during the commissioning phase, the operator, for example, to slowly drive the spindle even when the safety zone is not closed or is not cleared. So with open safety doors. The safe limited speed, in our case, it's limited to 8 millimeter per second maximum. So you are allowed, for example, in the jog mode, to drive up to 8 millimeters per second, but you can also perform a fully automatic operation, for example, run a complete program with safety reduced speed, maximum, as I already said, 8 millimeters per second. These three functions you can activate from the outside with the safety zone box. The last function is only an internal threshold or an internal limitation. It's the so-called safe maximum speed. This is just a threshold that you don't exceed the maximum speed for each joining system. For example, if we're talking about joining our NCFH with maximum speed 300 millimeters per second, the safe maximum speed threshold in the drive is always parameterized of 110 millimeters per second. This means maximum speed plus 10 millimeters per second for each joining system, just to avoid any malfunction of the system when the operator, for example, insert a not allowed speed for the joining system. So these four safety functions we are currently using when with the IndraDrive safety option S4. A short overview again. Safe stop 1, SMES, as I already said, and normally used for the emergency stop function, or if you're using, for example, a light curtain. Safe stop 2, SME2, is used often in combination with safety doors or safety gates, and a safe limited speed, SMM1, in combination with the SMSD2, for example, if you want to use a mobile panel and give the operator the possibility to move the system with slow speed, even if the light curtain or the safety door is opened. And the last one, safe maximum speed, simply in threshold to avoid any damages on the system if the speed is set too high. Now the use of these single functions. So SMES is used for emergency stop, two-hand control device, safety laser scanners, more or less the same like light curtains, and the light curtain itself. Safe stop 2, SMSD2, is often used for safety doors, safety gates, and I explained it already, SMM1 always only in combination with SMSD2. This needs to be activated. Then you can additionally activate SMM1 to move the spindle with slow speed. Here you see our drawings. Here you see each channel, each safety function has two channels. Channel 1 is always combined here with some safe pulsed outputs. Here we have the standard 24-volt supply, and here we have pulsed outputs for channel 1 and also a pulsed output for channel 2. If you are using a safety PLC with also safe pulsed outputs, you can directly connect it to your safety PLC outputs like it's written here. So this is only useful when you are not using a safety relay or something. If you're using normal switches, then you can wire it like this. Otherwise, you can directly connect these inputs from the safety zone box directly to your outputs from the safety PLC. Each safety function has two channels. Here you see SMES, SMSD2, and SMM. Now let's go a little bit into the details. Let's start with the SMES. We have two normally closed contacts. Both contacts have to be operated in the same time. That's really important. So if you're using a safety PLC, it's really important that you set the output signal to both contacts exactly at the same time. There's a really low threshold running inside of the drive, which are checking if the contacts are at the same level every time. The safety status: if we have an input of 0 volt, the safety function is active. This means no movement is possible. If the safety zone box in this case recognizes 24 volts, the movement is possible and the safety function is inactive. I already explained this one. If you're using a safety PLC, you can directly connect the outputs here from the safety zone box. And important is, if you're not using the IndraDrive function, you need simply to make a bridge. You don't, please do not leave it unwired, because otherwise this function will be always active. So for example, IndraDrive is always used for the emergency stop, but if we are going to the next step, exactly the same description. If you are not using the IndraDrive T2 because you are using, for example, a manual workstation with a light curtain, please simply make a bridge and do not let the inputs unwired. Otherwise, you will always have an active IndraDrive T2 safety function. So this is really important. For the SMM1, you see here we have two normally open contacts. If you are not using the safety reduced speed, you can simply leave these inputs unwired and nothing is happening. Okay, so now here you see, for example, a setup if you are using more than only one drive in the same safety zone. So here, for example, you see a setup with one safety zone module or one safety zone box and up in 3 different drives. So each drive of us are parameterized as a so-called zone master. So if you're using 3 spindles in one safety zone, you can use one safety module. So you only need to wire one time your e-stop, one time your SMSD2, or also the safety limited speed. And this will be activated for each drive in the same safety zone. To get this set up, you can simply order 1 additional or 2 additional safety zone cables. Then you can make a circuit like this. Important is you need to change the configuration of the so-called zone nodes, because each drive of our system are parameterized as zone master. If you want to use it in this configuration, you need to change one single parameter of the safety function for these 2 drives in this case. And of course, up to 25 drives you can put in one safety zone. So you don't need, the important message is, if you're using the drives in the same safety zone, you don't need to use one safety zone module for each drive. You can use one for up to 25 drives. Okay, let's continue with the IndraDrive Cs, which we are using for the NCFE joining module. Here the safety functions are a little bit limited. Here we have only one safety function. It's the so-called Sto Safe Torque Off. If you have a look at the diagram, you see what is happening when the STO gets activated during the spindle is running, in this case with full speed. You see the spindle has no controlled stop, like for example with the previous SMES. So here simply the power of the motor will be cut off, and if there is no additional brake or something, the spindle will slowly go down. So there is no controlled stop, and this is really what you need to take care of if you're working with the STO. Then we're also using the old emergency stop input of the drive. That's one single input, one digital input, and here you see the STO function, also 2 channels. Just the setup is more or less the same like SMES or SMSD2 with the safety option S4, but additionally here we are working with this e-stop function. So this e-stop function, or let's start with the STO function, it's more or less, as already said, the same like SMES or SMSD2, 2 normally closed contacts. Active, safety is active when an input is 0 volt, and inactive when the input is 24 volts, and also the same configuration if you're working with a safety PLC, you can directly connect your safety outputs from the PLC directly to the inputs of the drive. And this message here is really important. Only activate this function when the spindle is already stopped. Otherwise, let's jump back 2 slides. You will see you have an uncontrolled stop of the spindle, and this is not how it should be. So this is why we are working in this case additionally with the so-called e-stop input. This is only one channel, so it's not completely safe. This function is used to stop the spindle by emergency stop. So if someone in the machine, for example, is pushing the emergency stop button or is opening the safety, then this e-stop function should be activated. Here it's active, so movement is possible when we are receiving 0 volt, and it's inactive when we are receiving 24 volts. Then the movement is possible. And this is how it should start when you want to stop the spindle with the NCFE. First of all, please put the e-stop input to 0 volt, then the e-stop will be activated. We are also talking about stopping times lower than 100 milliseconds, always depending on the used type of joining module. And then you can additionally activate the STO function after 250 milliseconds safe delay, and then you are all right. So you see, here we have an uncontrolled stop in the worst case if the e-stop is not working. So generally we say this STO function you should not use in combination with a light curtain because it's too dangerous, and also with a two-hand control device. But we are talking about this later when I show you how to determine the performance level. Okay, let's have a look at some typical appliances. Let's start with the most common used one. Is this so-called safety light curtain. I think everyone saw this already. So we have a protection of third party. Operator can do things during operation, and of course the handling is quite easy. The disadvantages are no protection of parts that may possibly accelerate it out. In some joining process, that's the case. Regular measurement of over travel is necessary, normally 1 time a year, and expensive when using a high resolution light curtain. The next one is the safety door. Advantages is protection of third party. Operator can also do things during operation, and you have and protection of parts that may possibly be accelerated out. An over travel measurement is not necessary if the door is safely locked until the standstill till the joining process is over. And no danger by stopping the joining module if the door is also locked during the movement. Disadvantages, handling because you are losing accessibility, and also it's pretty expensive. So the next one is more or less from the functionality the same like in light curtain. It's the so-called safety laser scanners. Also protection of third party. Operator can also do things during operation and easy handling. More or less the same like the light curtain. You also need a regular measurement of over travel 1 time a year, at least 1 time a year. And it can also be expensive when you're using one with a high resolution. And also no protection of parts that may be accelerated out. Another one that's from terms of safety, from my point of view, the best thing, it's the so-called safety gate. So you have a complete closed safety zone. Protection of third party. Operator can also do things during operation. You have a protection of parts that may possibly accelerate it out. No over travel measurement possible, and no danger by stopping a joining module. Disadvantages, it's pretty expensive, and you're also losing cycle time, and sometimes also you're losing accessibility, and sometimes also cycle time. But there are safety gates available which are quite fast. They are opening so fast and and closing so fast. So normally it hasn't got a big influence on the cycle time, but of course they are pretty expensive. And last but not least, the classic, the two-hand control device. It's pretty cheap, and a small distance to the danger area is possible, but it always depends on the over-traveling stopping time. But the disadvantages are pretty high. You have no protection of third party. You have no protection of parts that may possibly accelerate out. There's a regular measurement of over-travel necessary, and also the operator cannot do any other stuff during the joining process is running because he always needs to push those 2 buttons. Okay, so now let's come to the determinate of the performance level. Generally, I split it up to 2 different steps, one with an automatic component supply and one with a manual component supply, so more or less in real manual workstation. So what you need to do is, first of all, you need to identify the potential risks. So systematic identification of foreseeable risks, intervention, unintended behavior by the operator. For example, imagine a manual workstation with a light curtain. It always can happen that the operator for some reason is crossing the light curtain. You need to be aware about this. And you need also to keep in mind the operating conditions of the machine. There's a normal function, but there also can be a malfunction also from the environmental. For example, if you imagine a blackout or something, you need to make sure that the operator do not get hurt even if you have a blackout. So you need also a brake or any additional additional safety function to the drive, because with a blackout, the drive is not working anymore. The second step is you need to evaluate the potential risk, severity of harm, and also the probability of occurrence of that harm. The third one is choose your safety function to avoid the potential risks, always depending on the used safety goal. So let's talk about the three different risks from our joining system. The first one is prevention of unexpected start. So we just want to avoid the start of the system when the safety zone is not free of obstacles. For example, manual workstation, someone has crossed the light curtain, laser scanner is crossed, or even the emergency stop button is active. So we need to avoid that the system is running. First risk. The second risk is the safe stop during the operation. So this means also, let's imagine the manual workstation, light curtain, the spindle is doing his process, idle stroke with 250 or 300 millimeter per second, and someone is crossing the light curtain. You need to make sure that the spindle is stopped as soon as possible to avoid any harm to the operator or to avoid any damages. That's the second risk. And the third one is dropping under gravity. We need to avoid that the spindle is moving because of the tool weight, even if or when the motor is powered off. That's why the most of our joining systems has included holding brakes, just to avoid that the ram is moving down because you have mounted a heavy tool. So these are the three risks. The first one is prevention of unexpected start, just to avoid that the system is starting when the safety zone is not free. Second one is the system is already ready to make sure safe stop as soon as possible. And the third one is dropping under gravity to avoid that the ram is moving down when the motor is powered off. So now let's imagine a machine with the automatic component supply. So first of all, well, that's explained quite easy. Here we are having the PLR, means performance level required. So the first step is severity of injury. So is it slightly or serious? So with a joining system, even if low forces, you can always have some serious injuries. That's why we are always starting here. The second step you need to choose is the frequency of duration in the danger zone. Are you only a few times in the danger zone, just for example, for some maintenance or something, or you're frequently in the danger zone, for example, a manual workstation where the operator always needs to manually apply the part into the machine. So here, first of all, we are talking about an automatic component supply. So we can say we are only a few times in the danger zone. The third thing is possibility of avoiding the hazard or limiting the injury. Possibilities, it's hardly possible, or it would be possible if you're reducing the speed constantly to lower than 10 millimeter per second. 10 millimeter per second is per definition an slow speed where the operator has the possibility to react of this danger. That's just for information. So if you're below 10 millimeters per second, you can say, okay, if something is happening, the operator can recognize it and get out of the danger zone. If you are above 10 millimeters per second, it's hardly possible. So if you don't want to lose too much cycle time, because who wants to run a machine with only 10 millimeters per second, you will lose a lot of cycle time. That's why it's always hardly possible. Well, you can use P1 if you are, for example, in a laboratory or something, and you're using, we had this a few times already, where people are always activated this SMM1 function just to avoid a performance level D. So you can also get performance level C with our joining system. If you are in a laboratory and just do some trials a few times a day where the cycle time is not too important, you can also reduce the speed frequently to lower than 10 millimeters per second. That's possible, but in the normal situation for normal assembly lines, this is not possible, or it's only hardly possible. Okay, so now we have an automatic component supply, and now, okay, we should get a system which is covering the performance level D. So here you see the whole system which you can use. You can use the IndraDrive C with safety option S4 and the safety zone box. And you can also use as a joining module the NCFN, the NCFH, NCFS, NCFB, NCFT, the NCFR. You can also use the IndraDrive Cs with the safety option L4, only STO, with the NCFE. And you can use these features and safety functions from the IndraDrive, SMES, SMSD2, SMM1, safe maximum speed, and also the STO, if you're using a safety door or a safety gate. So that's something for performance level D. Here you see how you can avoid the single risks. Here, first of all, the unexpected start. You can also always use the SMES or also for the NCFE STO, because STO is also reachable with performance level E. Safe stop, you can also cover with SMES and with the E-stop function for the NCFE. And dropping under gravity, you just need to keep in mind our maximum tool weight for each joining module. For the most cases, it's lower than 100 kilogram, or with our small one, only 5 kilogram. For the NCFS, it's 25 kilograms. So please have a look at the data sheet. And then we can make sure that the holding brake is exactly avoiding and dropping under gravity when the motor is. Okay, so now let's have a look at a graph for the manual component supply. And here you see the difference is only the frequency or duration in the danger zone. So now we are not only a few times in the danger zone, now we are frequently or even permanently in the danger zone. This means here we are directly jumping, because also the avoiding of the hazard is only hardly possible. We are jumping directly to performance level E. And if we have a look at performance level E, well, there is more or less only one system available from us till now. We have an NCFN with a special safety brake. So we have two safety channels. The first one is the IndraDrive with all his safety functions. And the second one is the safety brake in the spindle. And even if the drive is faulty, please remember, I just talked about in blackout. So even if you're imagining a manual workstation with a light curtain, well, the possibility is not too high, but you need to cover everything. So if someone is crossing the light curtain and this time you have a blackout, you need to make sure that the spindle is also stopping just in time. And this will not happen with the drive, because if he has no power supply anymore, he will not stop the spindle in time. That's why we are also implemented in second safety channel. That's the that's the safety brake. And if the drive is faulty for any reason, the safety brake will cover you. And with this setup, you can use a light curtain, a laser scanner, or even a two-hand control device. Okay, now you see the problem is always we have a safety function for the unexpected start, so it's the SMES always, or with the NCFE STO. But the big problem is the safe stop. So here for all of our joining systems, we cannot cover the safe stop. The only exception is the NCFE safety brake. There are also possibilities which the machine builder can always do. For example, some external brake. This is always possible, but from our standard joining system, we recommend to use only the NCFN for these cases. So dropping under gravity is manual component supply. For some manual workstations, you should choose your tool weight 50% less than usual. So for example, if you have 100 kilogram with an NCFN, you should use only, sorry, for the NCFH, you should only 50%. This means maximum 50 kilogram, and then everything will be all right. Okay, now responsibility, the risk analysis. You always need to do a risk analysis, which is always done. Everything is in the responsibility of the machine builder. For example, how you can cover unexpected start, stopping and lowering under gravity, calculation of performance levels, the easy thing what we did. So it's shown quite easy. It's much more complicated, but that's the easy way to explain it. Also testing function, consider maintenance plan, for example, to frequently check the safety brake. For semi-automatic systems, enable the automatic brake test. We talked about this in the second part. Measure and record the stopping distance. For example, a light curtain, which should be done one time a year. And adherence of directives, especially the directives for accident prevention and operator protection. So that's the responsibilities regarding the safety. Okay, so this was the last slide from our safety. If you have any questions, please let me know. Otherwise, I will continue with only 2 more slides and then we're already finished. I would like to use the chance to present you our Joining Competence Center. So since last year, the Joining Competence Center is at Kistler a part of the joining system business. We can check every application for feasibility. I'm doing this with one of my colleagues. We can, for example, calculate the thermal utilization of the motor and drive. We can calculate your cycle time, the estimated lifetime of the spindle, the parameterization, the maXYmos. For example, we can give you some hints for the sequence, evaluation, communication with PLC if you want to share or transfer some values to the PLC and so on. We can give you some hints for it. And what's needed for all this is precise calculation. It's important for us to receive the necessary information. That's why we just set up some so-called application checklist for joining systems. This you can fill out. You can, for example, grab it from the responsible safety representative, and if you send it to him, he can forward it to us, and then we can calculate exactly your cycle, and we can also recommend you a joining system. And also, if we are talking about some customer trials, since the beginning of this year, we have a so-called universal manual workstation. This one here with the cabinet for at our production center in Lauch, where I'm actually sitting. These trials can be done up to 100 kilonewton. You are always welcome to visit us, but if you, for example, don't know what is your maximum force of each joining process and so on, you can also have the possibility to send us some parts with some tools and so on. You can contact us directly and we can perform the trials, or you can have a look at our production center Lauch, visit us, and we can do the trials together. So that's what this universal workstation is built for. Afterwards, you will receive a report with all the necessary information. So just for your information, if you need to determine your joining force for example, for a new joining process, please do not hesitate to contact us. We can do some trials here at Lauch. Okay, so now the last part was quite fast, only safe, and a few words about our new Joining Competence Center. So now if you have any questions, please do not hesitate to ask. There's one question: what is mean by regular measurement of over travel? Well, this means if you have a light curtain, for example, you need the time and also the displacement value for your over travel. This means you need to make sure that when you're crossing the light curtain, you can say, okay, with full speed, the spindle is, for example, traveling 20 or 30 millimeter plus. That's what's meant with regular measurement of over travel. You need the over travel distance, which is measured, for example, by a light curtain. That's some safety restrictions you need to take care of. You need the time and also the over travel distance when the light curtain is crossed till the spindle is finally stopped. Any more questions regarding safety or our Joining Competence Center? Okay, well, the next questions are a little bit topic, but anyway, CSV files are never included in the backup. You need to export CSV files manually from the history curve buffer to a pen drive, for example. They are not included in the backup. maXYmos Plus software is not free for download. You need to order it. Only the maXYmos base version is free to download. And the third question was how we can write serial number to the drive. You cannot write in serial number to the drive. You need to transfer the serial number to the maXYmos NC, because the PLC no direct connection to the drive. Or what exactly do you mean with a serial number? If you're talking about the part ID, for example, you need to transfer it to maXYmos NC. There is no serial number available in the drive. Well, it's a little bit off topic. Maybe we can talk about the history curves and and stuff like this privately, because I just want to have questions now for this same topic or something. We can talk about this, but maybe private. Then I can show you how you can download your curves. Are there any questions? If not, I would like to give the word to my colleague Valentina back. So looks like my colleague is not available. So if you do not have any additional questions, I would like to thank you for your patience, and also hopefully you saw all the 5 parts. If not, there are some recordings available from our website. So I just want to wait for my colleague Valentina. No, just a moment, please.
Okay, I see that there are some questions in the Q&A box. I wait a second and we will answer them immediately.
So I already answered the questions from the Q&A box. I only saw the 3 ones. Oh, off topics.
I saw that there are some private questions I received privately, so I want to double check that everything is okay.
All right.
Okay, now I saw you answered them all the questions. So if there are any more questions, please do not hesitate to write them in the Q&A box on the right side of the screen. And I remind you that the webinar has been recorded and it will be published on our website. And we will, you can contact us at our email address is valentina.kelly@kistler.com. And thank you, and please subscribe to our newsletter for receiving more webinar invitations. Okay, thank you, and have a nice day.
Also, thanks from my side. Goodbye. See you soon.